Welcome. Today we will continue to discuss the V wave control, constant V wave control. So, first thing, so the variation of the terminal voltage with frequency is shown in this figure 1, the V wave relationship for V wave control. So, at rated frequency, voltage is rated voltage V rated. Above the rated frequency, voltage is constant at the rated voltage, and below the rated frequency, the V by F ratio is constant, that is V rated by F rated, except at very low frequencies where the V wave ratio is increased to keep the same maximum torque and flux per pole at the rated value. So, above the rated frequency V is kept constant at V rated, below the rated frequency V by F ratio is kept constant except at low frequencies, and at low frequencies, that is close to 0, V by F ratio is increased to keep the maximum torque constant and flux per pole constant at the rated value. The figure of a variable frequency control scheme is shown here. So, you have the VF, VS, that is variable frequency, variable voltage source feeding the induction motor, and for the variable voltage, variable frequency, variable voltage source, the V star is the command voltage and F star is the command frequency, and the command voltage is obtained from the command frequency V star through a flux control block. So, this is the flux control block. This maintains the proper V F relationship, and F star is obtained from the FR through a delay. So, in this VF variable frequency drive, motor is fed from a variable frequency variable voltage source VF Vs, V star and F star are the voltage and frequency commands for variable frequency variable voltage source. Flux control block produces voltage command V star for VF Vs in order to maintain the required relationship between V star and F star. The delay block ensures that F star changes slowly, so that motor speed can track the changes in F star frequency command, thus restricting the motor operation for each frequency between synchronous speed and maximum torque point. Variable frequency variable voltage source can be a voltage source inverter VSI or cycloconverter. Next we will discuss the slip speed control. The maximum torque occurs at the slip Sm. For slip S less than the max Sm, the speed torque curve is nearly a straight line. That means the portion of the speed torque characteristics between the synchronous speed and the maximum torque point is nearly a straight line. Since the machine speed torque characteristics are different frequencies for the slip between the 0 and Sm, that is the synchronous speed and maximum torque point, are approximately parallel, they are parallel straight lines. So, for a given torque, slip speed is the same at all frequencies, as you can see it in this figure, figure 3. So, this figure 3 shows the torque speed characteristics at 3 different frequencies f1, f2, f3 with constant V wave control strategy. So, at different frequencies the portion of the at the 3 frequencies, the portion of the torque speed characteristics between the synchronous speed and the maximum torque point, they are parallel straight lines. So, for a constant torque T1, the slip frequency FSL is same because they are parallel straight lines. So, the drop in motor speed from the no load speed, that is k omega s, where k is the ratio of bit of the f by f rated. So, k omega s is the no load speed, or you can say it is the synchronous speed at the frequency f, is the same for all frequencies. So, for a given slip speed, motor current and torque have the same value for all frequencies obviously. Thus, motor current and torque can be controlled by controlling the slip speed using a closed loop speed control scheme. So, the motor current and can be restricted within the safe limit by limiting the slip speed. This principle is used in closed loop speed controls for limiting the current within a permissible value. So, for speed control above the rated speed, so f is more than f rated, so k is greater than 1, k is the ratio between f and f rated. Since applied voltage is constant at the rated voltage, both flux per pole and the maximum torque are inversely proportional to the frequency, because the product f phi is constant when voltage is constant. As the frequency is increased, flux is inversely proportional to the frequency. So, torque speed characteristics for high frequency above the rated value are shown in figure 4. So, this is the speed torque characteristics for frequency above the rated speed. At rated frequency, the speed is rated, which is omega rated, and corresponding to that torque is the maximum torque. For frequency f1, f2, f3 more than above the rated frequency. So, the maximum torque is inversely proportional to frequency, because product f5 is constant. So, the torque speed characteristics are as shown in this figure 4. So, motor operation is constrained between the synchronous speed and the maximum torque point. So, slip is between 0 and Sm, and it has a small value. So, at a given stator current, the slip speed omega SL increases linearly with frequency and power is constant. So, constant torque mode and constant power mode are shown in this figure 5. So, in this figure 5, the modes of operation, that is constant power mode, constant torque mode and constant slip speed mode are shown, and variations of torque, power, voltage, stator current IS, omega SL with frequency are shown. So, as you can see, from 0 to rated frequency, the drive is operated in constant torque mode. Above the rated frequency, the drive is operated in constant power mode, but that can continue up to a certain frequency, beyond which power cannot be maintained, power will again decrease, that is constant slip speed mode. So, during the constant torque mode, torque is constant because flux is constant at the rated value, maximum torque is constant, because maximum torque is constant. By maintaining the slip speed constant, the torque can be maintained constant. So, torque is constant. So, voltage varies linearly with frequency except at low frequencies, and current is constant because slip speed is constant, torque is constant. So, current is constant because torque is constant and speed increases linearly from 0 to f rated, power varies linearly from 0 to rated frequency. Again voltage is also linearly varying linearly, current is constant. So, V and I product is power. So, P and V will have the same graph. So, at low frequencies, when the voltage is increased, then the power is also increased. So, that maximum torque is maintained constant. So, this is the constant torque mode, slip speed is also constant, and above the rated speed torque, above the rated speed, the voltage cannot be maintained in according to V wave ratio. So, voltage is kept constant at the rated value V rated, because current is constant, power is also constant. So, this is the constant power mode. Torque, the maximum, the flux per pole is inversely proportional to speed. So, torque is also inversely proportional to speed or frequency. So, slip speed increases linearly in this zone, constant power mode. So, above the so constant power mode can be continued up to a certain frequency and certain speed, beyond which even voltage cannot be increased, voltage has to be reduced. So, so that is power also reduces with speed, that is the constant slip speed mode. Slip speed is maintained constant, but voltage is reduced and power reduces. So, torque also reduces further, maybe according to square of the frequency and speed. So, these are the torque speed characteristics and modes of operation for and variation of voltage, current, torque, power and slip speed with frequency. Thank you for attention.